Hi, and welcome to the Tech Recruiting with the Alignment Framework course. Hi, I'm ALISON, founder and CEO of Recruiting Innovation, where we offer the Tech Recruiter Certification Program, the Alignment Framework, and the Ernestine McClendon Talent Grant. After 10 years in the recruiting industry and experiencing firsthand the perpetual awkward of recruiting for technical roles that I did not understand, I created the Tech Recruiter Certification Program to provide recruiters what they need to know about software development and the various roles on the product team in order to help recruiters feel empowered, knowledgeable, and confident in their work as technical recruiters. As a recruiter, have you ever had an awkward conversation with an engineer or technical hiring manager? Have you ever felt the need to ask clarifying questions but didn't really know what question to ask? Have you ever wished that you could just stop the awkward and start the conversation? I know I have. Being constantly uncomfortable in your work because you don't quite understand the industry you recruit for is unsustainable. And honestly, it's not fair to be expected to shine day in and day out without proper training to truly excel within the tech industry. I created the Tech Recruiter certification because I love this industry, and I want you to have what you need to deliver incredible service and great talent to your teams and to our industry at large. Today, I will provide you with a technical understanding and a framework that will change the way you approach these conversations. Soon, you'll be having confident, credible, and even fun conversations with technical candidates, hiring managers, and colleagues. This Tech Recruiting with the Alignment Framework course is the recommended first course within our technical recruiting training program. Once you've completed the lessons in this course, you'll be ready for the technical courses. My goal for this course is to get you up to speed with the right knowledge, skills, and tools to have you successfully recruiting top talent for your open technical roles. I also think it's critical that we as recruiters understand that we are the professional builders of teams. As such, it is inherently our responsibility to be the drivers of change in the tech industry. I fundamentally believe that it is the recruiting industry that is and should be on the forefront of diversifying the tech industry through intentional recruiting practices. To support that value and to create opportunity for talent from all walks of life to enter into the exciting world of technical recruiting, in the summer of 2020, I launched the Ernestine McClendon Talent Grant. The Ernestine McClendon Talent Grant seeks to attract, train, mentor, connect, and build community for aspiring tech recruiters from underrepresented talent groups. Named after Ernestine McClendon, the first agent for Black talent and the first Black talent agent, we seek to continue her legacy by creating opportunity and connection for groups who have often been overlooked or held back professionally. This Talent Grant program is a 5-month program that happens twice a year and is designed for talent from the Black, Indigenous, people of color, LGBTQIA+, and disabled communities to have opportunity to cultivate a rewarding career, not job, career in the tech recruiting industry. We are always looking for Talent Grant applicants, mentors, and sponsors who want to help us build this diversity pipeline for the tech recruiting industry. After all, what better way to drive diversity in tech than to build diversity on our recruiting teams? If you'd like to learn more and get involved, please visit recruitinginnovation.com and click the grant option in the top menu. We'd love to have you join us in bringing about the change that we all want to see. Now, on to the main event. One of the top complaints I hear from tech recruiters is that learning about the tech industry is difficult. It's modular and piecemeal. We learn a bit about a role over here, we learn about another role over there, and then we try to fill in the gap by doing some ad hoc internet research. What we learn from internet research is often not designed for what we as recruiters need to know, but is most often for developers themselves, which means it's far too technical to be useful for us. This can create a very Frankenstein understanding of the industry we recruit for. But that all changes today. In this course, I'm going to introduce you to the software development lifecycle, also known as the SDLC, leveraging the tools used directly within the software development process itself. I'm going to do it with a big picture approach to lay the foundation for your technical understanding, and then we'll fill in the details so that you leave this class with a proper orientation as to what developers do and why. The software development lifecycle is the engineer's process for developing, altering, maintaining, and replacing software. It begins with a ticket and it ends with live code. Once we understand the process that developers follow through their work, we can better understand what technical candidates are sharing with us during our interviews with them. I know from firsthand experience that it can feel like what developers do is some sort of technical magic. But the reality is they have a discrete 5-step process they follow every single time. And by orienting ourselves to the key steps in their journey to deliver their products, we provide ourselves with a roadmap for understanding what it is that developers do. This is a hands-on session, so be sure you've downloaded or printed the course materials and handouts to take notes on. Later, these notes will become your technical handbook for future reference. This brings us to the first tool in the alignment framework. Pulling from the user experience tool of the journey map, we're going to leverage this approach to help explain the software development lifecycle in a structured storytelling way. Journey maps are the visual representation of the key stages from beginning to end required to accomplish one's goal. UX researchers use journey maps to map the journey an end user takes when completing their goals related to a specific product. Mapping a user's journey as they are doing and thinking things to solve their problems allows product teams to gain insight into the perspective and experience of people using their product. At Recruiting Innovation, we leverage journey maps in a similar but different way. We take the journey map and apply it to the workflow of a particular role rather than mapping the journey a user takes using a product. To relate this back to our experience as recruiters, we have a 6-stage process between getting a new role and making a hire. This image gives us an introduction to how a journey map can be used to understand a workflow, in this case, a recruiter's. As recruiters, our process starts when we get a new role to recruit for. We then go through the process of sourcing, outreach, qualifying, interviewing, and then hiring. As we go through our recruiting process, we are doing and thinking certain things per stage. Regardless of whether we're recruiting for tech, marketing, operations, you name it, this is our consistent workflow from beginning to end. Similarly, for software developers and any technologist, there's a discrete 5-stage workflow for developing software. Let me walk you through the Alignment Framework Journey Map template for the software development process. Across the top of the table, you see the 5 stages of the software development process: research, design, build, test, and deploy. As developers follow this 5-step process to build software, they are doing and thinking certain things to solve for the needs of each of these stages. This 5-stage process holds true for front-end, back-end, mobile, and data engineers in every role on a software development team. Once we as recruiters have a good grip of this foundational process, every other aspect of our work and understanding improves as technical recruiters because we now have a structured understanding of how software is developed. Understanding the SDLC in this format provides us with a roadmap for understanding what our technical candidates and hiring managers are sharing with us throughout the course of our work in technical recruiting. Now, let's walk through the software development process, leveraging this journey map as our guide. When building or maintaining code, a team will map out and track needed bug fixes and new features. Individual pieces of work will be assigned to tickets, and tickets get prioritized based on product delivery timelines. Developers are either assigned tickets or they simply take the next ticket in the queue to work on. Now, I've mentioned this earlier and it bears repeating. There are 5 key roles to a software development team. Of course, there's front-end development, back-end development, and DevOps development. But a product won't get off the ground and provide an excellent experience without also including UX design and product management. Because of this, you'll often hear me refer to technologists in this training. A technologist is the umbrella term I use for anyone working in technology in the software development process, even if they themselves do not code. Now, working through the process of developing software, all technologists follow the same 5-step process. And depending on their team's dev environment, their process might be closer to Agile, closer to Waterfall, have elements of Lean, or some combination. Regardless of the environment, the technologist's workflow will touch all 5 stages of the process and sometimes concurrently. Let's follow along to learn more about each stage of the software development lifecycle. During the research phase, the technologist seeks to understand everything needed and expected from the ticket or new project. Having a thorough research process is critical to a project's success. Development can be a very expensive endeavor, and the more upfront work that can be done to ensure the who, what, how, and why of a project, the less course correction will be needed once coding and development is underway. The research phase includes working to understand all of the requirements of the ticket, from what the code should accomplish, the dependencies and constraints that exist, and the use cases to be satisfied. In the research stage, the technologist may be reaching out to colleagues in different areas of the product team to gain a full perspective of the ticket, what it should deliver, and how. These colleagues could be in the user experience team, the design team, and development team such as front-end, back-end, and DevOps. The goal of the research stage is to gather necessary information to complete the ticket or project. They'll be asking questions such as, what is needed to complete the ticket? What are the requirements, or what does the code need to do? What are the dependencies, such as what is the code relying on, and what code currently exists in the technical platform that this code will need to play nice with? What are the use cases, such as when will this code be used, for example, during checkout, when logging in, etc.? What user data do we have? How are our users currently solving this problem? What are the mental models that will drive how an end user expects to be able to interact with this product? You'll learn more about how each of the key technical roles on a product team experience the research stage in the individual technical training courses. But for now, know that a solid research phase is critical to the success of a project, and that every technical role does research before they begin to move on to the rest of their process. Once the developer gains a comprehensive understanding of what is expected and required from the ticket or project, it's time to move on to designing the solution. Once the technologist has a full understanding of the expected result of the ticket and all the data inputs and outputs required, then they begin the stage of designing a solution. See the design stage as also the planning stage. This is where the spider in the web work begins, and each role begins to pull the various threads of requirements and expectations and begin their process of weaving them together to create a cohesive plan that incorporates all of the data points. Key elements included in the design planning are architecture, the high-level structures of the software system, programming languages, the team's choice of language developers use to create software programs, scripts, or other sets of instructions for computers to execute, frameworks, a packaged set of features that enforces a specific architectural approach, and libraries, a structured collection of resources that improve the speed and consistency of writing code. There's also use cases, the set of possible sequences of interactions between systems and users in a particular environment related to a particular goal, and where possible, developers will plan on reusing existing code in their solution. This increases efficiency for the overall code base. The level of design required depends on the size and intricacies of the ticket. If the ticket is for a bug fix, they can be pretty cut and dry. Go in, find, and then fix the error. If the ticket is for a new feature, such as creating a chat box or the ability to filter data in search results, then that will require more design and documentation and collaboration than just a bug fix. It is important to realize that code never lives on an island. It's always connecting forward to the user interface that users see and back to the database layer where the data is stored and pulled from. So, designs will include all layers of the code that will integrate in order to satisfy the requirements of the project. Once the research and designs are ready, it's build time. During the build stage, a cycle of code being written and tested begins. Some of the key goals throughout the build process are efficiency, reusability, performance, and accessibility. This is basically where the rubber hits the road in the development process. The developer will either solo code or pair program the solution depending on the coding culture in their workplace. As they develop the code, they are tracking against their design plans to ensure that what is being built is what is expected from the requirements. Many developers take a user-centric mindset and consider accessibility throughout their build, ensuring that what they build is accessible for people with various disabilities. The build stage is also where any gaps in planning surface, such as a specific user flow that had not been previously identified. When surprises pop up like this, they get prioritized, designed, and quickly integrated into the build plans. During the testing phase, the key goals are to identify and fix bugs in the code and ensure the new code will integrate with the current code. Before testing begins, a test plan is developed, and the test plan can include the type of test that will be done, how the software will be tested, who will be doing the testing, and test scripts are created which will ensure consistency with the testing. The testing phase covers the functionality of the code while also ensuring that the new code will integrate seamlessly with the entire code base. Testing the code for full integration is critical before deploying the new code into the code base. If testing is not thorough, the risk is created that the entire software product goes down due to errors, and nobody wants that. There are multiple levels of testing that can be done. Types of testing include quality assurance, also known as QA, which is a process to verify that a product meets the specified requirements and customer expectations. There's system integration testing, also known as SIT, and this is a testing technique that verifies whether the system and its subsystems are working as expected without any technical issues. There's user acceptance testing, also known as UAT, and this is the final step of testing before the system is accepted by the operational user. With modern software development, testing and building go hand in hand, as we saw in the diagram for agile design. The old days of writing a bunch of code and then throwing it over the fence to the QA team to test are thankfully on their way out. As is done in agile, testing while building speeds up the development process, improves the final product, and helps developers learn and control the code that they are building. There's also the practice called test-driven development, or TDD, which has been gaining traction in the past few years. TDD is the process of building the tests first and then building the code to pass those tests. Once the test is passed, the code is approved to be deployed. The deployment stage is when the tested and approved code is integrated with the live code of the platform, app, product, or website. Code is deployed to production. When code is in production, it is live code in a real environment that can be used by the end users of the product. The goal with the deployment process is to push the code live with no issues, bugs, or causing the system to go down in any way. The DevOps team is typically the main team during the deployment stage. As with testing, sometimes during the deployment process, an issue surfaces that needs to be fixed prior to launch. This is where the developers on the project pop in to make any necessary fixes or updates. Deployment encompasses all of the processes involved in getting new software or hardware up and running properly in its environment. Deployment includes installation, integrating the new code with the live code, configuration management, tracking and controlling changes in the software, running the code, integrating new code with the entire platform, and testing, the final system integration testing before going live. Most companies operate on a standardized schedule of when code is deployed. This is called a release cycle. A release cycle could be weekly, every 2 weeks, monthly, or via continuous integration and continuous deployment, also known as CI/CD, depending on the standards of the organization. Once the code is deployed, the ticket is closed, and the developer is off to another ticket, and the cycle begins again. Let's cover a few of the main methodologies of software development: waterfall, agile, and lean. Here is a pretty well-known visualization of the difference between waterfall methodology and agile methodology. Waterfall methodology follows a sequential process where one stage of the development process is completed before beginning the next. Having its start in manufacturing, waterfall is quite rigid and constrained in its process as projects only move in a forward direction. Waterfall was a traditional mode of software development, leading projects to take 18 months to 2 years or longer to complete. This methodology allows for very little adaptation or course correction when developing software projects due to its linear development progression. As with all workflows, there is a beginning, a middle, and a final outcome. Between starting a project and finally delivering it, there are 5 stages to the software development lifecycle. As listed in this waterfall image, the 5 stages are design, build, test, and deploy. Agile methodology takes the same 5 stages of waterfall, but then applies them in short, quick cycles with smaller iterative outcomes. This approach supports iterative design as testing and product feedback happen constantly and concurrently, rather than simply at the end of the process. Agile methodology is the common approach with most modern and innovative tech companies. Similar to Agile's goal of increasing efficiency and learning, the Lean methodology is a model for software development inspired by lean manufacturing practices and principles. The 7 lean principles in this order are: eliminate waste, amplify learning, decide as late as possible, deliver as fast as possible, empower the team, build integrity in, and see the whole. The lean process is about working only on what must be worked on at that time, so there's no room for multitasking. Project teams are also focused on finding opportunities to cut waste at every turn throughout the SDLC process, from dropping unnecessary meetings to reducing documentation. You will often see Agile teams who also run lean processes. As a recruiter, having a good grasp of the industry you recruit for is critical to success. Knowing the fundamentals of the software development lifecycle will enable you to quickly understand the technical roles you are recruiting for. Whether you are in a conversation with an open developer role, with a technical hiring manager, or interviewing a technical candidate, understanding this 5-stage workflow that all development projects go through means that you can orient yourself to the bigger picture of what these technical folks are talking about when in conversation with them. The added beauty of understanding this structure and the key stages of how software is developed is that pretty much every role in the development team follows this 5-stage process in their workflow. That means whether you are speaking with a front-end engineer, a UX designer, a mobile developer, or a security engineer, you can follow this structure to ask meaningful questions and effectively learn about that person's work.